Well, good morning, everybody. We could get together. Hopefully, for today's conversation on the impact on plumbing's impact on the energy code, on the IECC. So today's class is going to be taking a look at this topic. Really, we've talked about over the course of our conversations for the past couple months every other system in the building process, right? We've talked about the concepts of design. We've talked about the systems that we find within the energy code specifically for um, wall design, air barriers, vapor barriers, air testing expectations. We got the mechanical systems, power and lighting systems. And that last area of conversation is really going to be the plumbing code and how the relationship exists with the energy code, how they correlate together, coexist together. Um, so, and that really is kind of the building on that conversation of what do you mean? Why? Why? Because when we understand why, we can figure out how, right? And that's a common theme for me in a lot of the things that we've talked about in the last couple of months, and especially last week even. But one thing I want to make sure that we understand is this is not going to be a course or a discussion of the plumbing code as much as it's going to be the conversation between the relationship. A lot of building departments and isolate and separate plumbing from uh, traditional construction inspections, right? We where I come, my home community, we always uh, give plumbing responsibilities to our health departments, right? They go out and they do all the plumbing inspections, and then we would just do building inspections. And so over time, we came to realize that those two things are not independent of one another; they build on one another. And so again, I think that's why it's important for us to kind of have that conversation to kind of round out our understanding of the building, and as we get into it. So when we think about the why, and I always try to reinforce this because I think it's important for us to remember. Why do we have an energy code? It's because we're trying to look at how we use energy in our building systems over their useful life. It's not just for a one-time snapshot, right? How is this building going to operate for its longevity? And the code is really, I think, intended to provide that flexibility to use innovative approaches and techniques to get to that goal, right? Just like the intent says. This is probably a well written intent statement because, again, it's designed to give us that flexibility. We can use new technology and we understand that buildings change. And we'll talk about that in the context of residential design, residential property projects throughout our conversation. But the one that's most, reticent with me right now is simply just replacing even a water heater tank. Right, my sister called me this week. She needs to replace her water tank, and so she asked all these questions about. Well, I had a company come out and they've given me these quotes, and here's 3 different systems and all the things that come into it. Which one's the best one, bro, as she would call me. And so really it gets into that conversation. Well, is this a my brain immediately went to, well, is this a building code conversation or is this an energy code conversation? Right? And how do they bridge together? Because as I'm evaluating of what the proposal she was receiving, I'm looking at it and thinking, well, yeah, this would be good for that, but this is better for this, and making those decisions to assist her as a homeowner, right? So again, understanding that's the intent of the energy code is to be flexible. The building code, whether residential or commercial, is really all about providing again those minimum safeguards, those minimum expectations for uniform construction. Right? We're looking at how does a building, what components and systems in a building make a building safe for both the occupants and the general public. And with that, we understand that the residential code has a series of plumbing considerations or plumbing sections, plumbing chapters in it, as well as what we see in the IPC, which is the plumbing code, right? And the plumbing code is there to, again, provide those basic understandings, those minimum understandings of how we design, install, and maintain those pieces of plumbing equipment, right? So again, for me, that's always been a separate, process. And actually, in Ohio, we'll begin on Tuesday, July the 1st. We begin the process of allowing departments, building departments and health departments to combine forces and building departments to take over the plumbing responsibilities. Because as we see in most designs, it's, you know, unless it's a septic system, for the most part, it's really the same process, and it's a more, you know, streamlined process to just use the building department to do the plumbing because it's part of everything we do. So again, that's a reality. So then, you know, so that kind of lays out the why, right? We're looking to make sure that we have safe buildings that have access to these different facilities and that use technology and innovative designs to be energy efficient in that process. But also, we have to remember the scope of the conversation we're talking about, right? Remember, the energy code in the residential section of the energy code gives us a definition of what residential building is. And residential building is a little bit different in the energy code than it is in our traditional residential construction code. Residential construction, we're looking more at that's 1 and 2 family dwellings, right? Maybe townhouses, 3 stories and less above grade. If we take that 1 family dwelling and make it 4 stories, we jump in the IBC. If we build that hotel, that R2, R3, R4, R1, R2, R3, R4, we're going to the commercial code. Well, the energy code says, well, we're going to treat residential the same, regardless of the method of structural construction. And so it says residential building is any detached 1 and 2 family dwelling, as well as townhouses and groups R2, R3, and R4, 3 stories or less in height above grade. So again, we have to understand what it is we're looking at in the scope, not only of the building, but also of the project. We'll talk more about that here in a second. But you know, when we get to those mixed occupancies, right, we get a building that's got a little bit of residential, it's got some commercial space in it. Remember, if it's under 3 stories, it follows residential. If it's over 3 stories, it's commercial. If it's a commercial occupancy, that's not one of those R2s, R3s, R4s, then it follows the residential provisions. So a lot of times when I've had a building that has multiple compliance methods or compliance sections on it, actually I would get this. We got to where we'd actually visually depict that, right? I'm all about the visual. You know, I'm a simple guy. And so what we would get was we would get plans that said, here are the units that are following the residential code. And here's the unit following the building code. Here's the units following the residential energy and the commercial energy. We see that once in a while, and maybe I've seen it in a couple plans where the hotel has said, we're going to have this many ADA compliant units, right? And this many designed for auditory versus visual versus whatever, those other specific designations for accessibility. And so again, when we see it like that, the one that come to my mind immediately, it was a visual depiction, right? There was an actual layout of the plan that says, here's my auditory units, here's my wheelchair units, right? Here's my visual imperative unit. So that again, you had that clear understanding of which ones are being used for which purposes. Same concept, right? In that delineation of this is residential, right? If we think about a hotel, right? The second floor of a 2-story, 3-story hotel can be all treated all through the residential code, right? That hallway, this is usually that conversation I get all the time. Was the hallway residential or is it commercial? Well, it depends on how you're accepting it as a building official, right? For me, it's residential. You know, in the context of the energy code, right? The energy code is going to tell me that I have to think about, again, uniform, consistent lighting. We're not going to put dimmers in a hallway that serves residential, you know, in a regular hallway. That's no different. I'll look at it from the context of construction from a commercial. I'm going to look for egress widths and all that. But from an energy code, it's just call it all residential. First floor is going to be residential to a point, and there's going to be commercial areas where we got the pool, the workout area, the little office areas, the lunch area, right? We can visualize how we would lay out and distinguish residential from commercial. And so that's how we, you know, when we talk about that mixed use, that's one of the ways I like to do that. And again, a lot of designers I work with, when we talk about it that way, they're like, you know, that's really a great way to kind of just make complete clarity as to what we're doing. Let's do it visually. You know, this is going to be this, and that's going to be the other. That further builds on this concept of what is, well, if we've got a definition for residential, then we have to have a definition for commercial, and commercial's definition is anything that's not residential, right? So again, simple. So again, we can kind of parcel out what's the scope of the conversation. But when we start talking about the relationship with the plumbing code, we really get into the scope of what is the work, right? And you know, my brain is very simple. I like a simple process. You know, I like my 4 pillars of energy code with my 4 pieces of each component, 4 pillars, 4 parts. And so when I look at the plumbing code, whether that's the residential or the residential provisions or the actual IPC, what I see is really 6 sections, right? 6 concepts. And the first is going to be fixtures, right? And fixtures, then we get into this concept of supply and distribution. If you had your IPC out and you looked at your chapter settings, you would see kind of this layout. We've got this concept of fixtures, this concept of how do we get the piping there? How do we get that water from here, from the source to the termination? That's going to be through a system of supply and distribution lines. Then we're going to have surface water heating equipment, right? What are we doing to heat some of that water to make it usable? And then we get into drains, right? Whether those are sanitary drains for getting rid of waste or storm drains for managing water flow. Again, drains concepts. Then we get into venting, which is sometimes a part of a little bit of both the equipment and some of those drains, right? But we got venting and traps, right? In order to prevent, to properly exhaust and prevent influx of that exhaust into a system, right? So we really got these main concepts that we see identified throughout the plumbing code. When we look at the energy code and that relationship, each one of those concepts has an energy component to it to some degree. When we think about fixtures, we think about controls, right? How do we control that fixture is the outlet distribution termination, right? So when we think about it from an energy perspective, how are we controlling that fixture? When we talk about the distribution system, the piping that gets it from the source to the termination, we think about insulation, right? So we have insulation. Surface water heating systems are obviously a major component in our residential and commercial energy code compliance. Drains, we start talking about heat water recovery, right? How are we going to use technology? We wouldn't have thought, who knows? It wasn't common 40 years ago to build thinking about what water was inside the waistline as it went out, and whether or not we could recapture some of that hot water, some of that conductive heat, and reintroduce that into our heating systems, right? But it's an option that technology and materials have made it easier to accomplish. We talk about pools. Those are a reality. They're maybe not necessarily the vent that we're looking for, but again, it was just something to throw in there. Keep the common concepts. But then when we get to traps, we talk about heat traps. Again, how to and that kind of concept. So I think when we look at this whole session of slides, which I forgot, let me apologize. I forgot to throw those into the chat. So I'll throw the slides into the chat. When we start talking about that, as we go through this session, this webinar, we'll kind of see each of those sections and how they correlate. Now, when we start off with fixtures, the plumbing code it provides for us a table that we can use to calculate the number of fixtures, right? The number of fixtures required. And so based on occupancy types, based on occupant size, that creates for us this requirement. We have to have so many spots to correlate back to to require in the building the minimum number of fixtures. We look at the residential, and the code tells us again that each unit, there are some minimum expectations for plumbing facilities, right? We're looking for, again, these expectations, minimum expectations. So we're used to those two concepts, that we have minimum number of plumbing, minimum number of fixtures in a building. We currently understand, and we understand that in that process, there's a relationship with our mechanical code, especially when we start talking, this example here of a commercial operation, right? We do the same thing in bathrooms, right? We have a requirement that we have toilet facilities that provides that water closet, lavatory, and bathtub. But then we also require that we have ventilation, natural or mechanical ventilation in that toilet room, right? Because we want to make sure that we don't accumulate too much uh, condensation, moisture, right, in that space. And so the same concept, we want to exhaust out, bad fumes as well as moisture that might accumulate in these enclosed spaces. And so we typically understand that plumbing code will interact with mechanical code through section 403. We talk about the minimum ventilation rates. And if we look down, we can see that and so what we'll do is we base that on based on the capacity of the room, the capacity of the facility gives us a number of fixtures, and based on that number of fixtures, then we get into how much ventilation air, right? So we zoom into those public spaces and public toilet rooms. We understand we have to provide an amount of air for each fixture. So 50 CFMs per fixture. So if I have 7 urinals and water closets in this room, then I multiply that by my 50 units, my 50 CFMs, and I get 350 CFMs of air movement in this particular room. We do this calculation throughout all of our mechanical plan reviews to verify that we get the right ventilation. We do something very similar when we talk about bathrooms, right? We go to bathrooms and we're like, in residential homes, we say, I need to have some kind of exhaust. Is it intermittent or continuous? Great question. You tell me, right? What's going to be required in your design? Where we interact with the energy code is we say, okay, we see you have these devices in place, these mechanical systems in place. So what is the level of efficiency and control of those fans, right? And so that's when we start asking questions about, again, how are we controlling those pieces of equipment? How are we making sure we get the right size, right? That we didn't oversize and put a 5 horsepower, fan in a room that really only needs a quarter horsepower, right? That we didn't oversize the system, and now we're gonna have this jet engine activate, sucking all the air out of the room, right? We do that all the time, and it's not just to make sure that we have the rights, not just to make sure we don't have overpressurization, but also to make sure we're thinking about energy conservation, energy use. And so we see here, we've got the rights, we've got this unit, this exhaust fan, we see the CFMs, we see the size, and then we know that we've got these other notes that say what kind of controls we're going to have, right? To run continuously during building occupied hours. During unoccupied, they'll remain off. That's what we want to see. We want to see the efficiency of the equipment and the controls associated with it, right? So that's one of those places where, again, we have that correlation between our different concepts. Again, section 303.2 in the IPC tells us that when we install materials, they have to follow manufacturer's installation instructions. That concept sounds very familiar. Why? Because it's universal against the code, right? The entire set, the entire family of codes. And so when we look at it in the context of residential systems, and we see this both in the IPC and in the IRC, we get this idea that when we install something, we have to install it to make sure it's protected, right? So that we're protecting it against corrosion, we're protecting it against accidental penetrations or impacts, right? When I go through and I hit, my son decided he wanted to put the TV in his room this weekend. So we went over and I got the stud finder and we went through the studs. We found the stud, right? And then I could nail in the nail to hang the mount, right? If I had a plate, then I would know that I'm in a space where maybe a line or something was there, right? I'm trying to protect. I'm going to put those pleats in place to protect against damage. That's a concept that we see identified in IRC, the IPC, for equipment, right? We can understand those concepts. Those are also concepts we find in the energy code, right? We're trying to address penetrations of our building thermal envelope, our air barriers, right? We're trying to protect those same concepts. So whether it's through the proper installation of materials or the proper protection of those plumbing systems, we're still trying to figure out if that plumbing line runs through my air barrier or through my thermal envelope, then not only am I protecting against penetration and damage from nails and other things like that, but I'm also going to make sure that it's properly sealed and gasketed. That's a requirement in both the plumbing codes, the plumbing provisions, as well as the energy code. We want to protect against uncontrolled, unregulated air movement for both fire protection, smoke protection, and thermal heat loss. So again, one code trying to accomplish 15 things, or one project under 15 different codes. I'm exaggerating. It's not 15, right? But again, our energy code goes through this process of, we've got an air barrier, we've got systems we're trying to protect the same way we protect our plumbing materials. And so it gives us this table, and in that table we see plumbing, wiring, and other obstructions, and what we're supposed to do to protect those and to install them in context of our air barriers and air sealing expectations, as well as our shower tubs, right? We've talked about before in our wall designs and in our air barrier designs that we're trying to account for these types of systems. So there's a relationship between the two. Install it properly, and then make sure that we didn't, in that process of installation, affect our air barriers, our air loss, our air and heat loss expectations. So again, a visual example reminder. So this might be something as simple as making sure we properly seal, as well as we properly insulate, right? Those are two different concepts that we see in buildings. And one of the realities that again exists, and I use my personal example for this one. When we bought our home, I bought my home. It's a tri-level home. I bought it and it was built in 2007, 5, 7, somewhere around there. And when we first moved in, we made the basement area underneath our master bedroom suite the office. And so one day my wife was upstairs, new house, we're going to take a nice long shower in her big garden, her big jacuzzi garden style tub. And so she's taking her bath, and I'm sitting downstairs in the office doing some paperwork. And like every once in a while, you just lean back and you look up. And I looked up and I noticed two little dots that were discolored. And I thought, well, I don't remember ever seeing those before, because I would have surely have brought that up and tried to paint over them, right? And so as I look at it, I'm staring at it. I do what every person does. You get up there, you stand on something, and you touch it to see what it is. Well, when I touched those two little circles, those little, probably about the size of a dime, they were wet. And I'm listening, and my wife's in the shower, and I'm like, in the tub, and I'm thinking, what is that? There's no water running. It's not a large amount of water. What is it? So I go upstairs and find out, she's taking a hot shower, hot tub bath. And what we end up finding out is that there was no insulation, right? There was a lack of insulation under that shower stall, right? So there was no insulation. And so the air, the temperature of the water was creating condensation in relationship to the exposed air underneath the shell, right? In this exposed area. And so that condensation was beginning to accumulate, would drop to the ground, and was starting to penetrate into that sealing system, right? That's exactly what we're trying to prevent against. We're trying to make sure that we have continuity and a set of designs that don't allow for that accumulation of moisture, right? So when we install it properly, the code would tell us that we need to think about the air barrier to make sure we don't have uncontrolled air movement through these systems. If we want air movement, that's fine. Control for it, right? Ventilate it. Make sure you're keeping it consistent and potentially dried or undried. Or when we start talking about humidity in the air, or again, humidity coming off of the shower stall or the bath stall, right? Because it's not like these are temporary uses that in every instance. There are times when the shower takes 5 minutes. You're done, right? Especially if you have no hair, it's 5 minutes, you're in, you're out. But there are times when you may want to sit in that tub for an hour, right? And keep re-adding more hot water. Oh yeah, keep that hot water, right? Well, then you're going to accumulate more potential thermal differential between the shell of the tub and the surrounding air. And so you're going to get condensation. It's going to create problems. Condensation is never good. We don't want to trap it inside our assemblies. And so again, that's where we're trying to control for that by insulating, filling these available spaces to prevent moisture accumulation. We do that through a variety of different materials, right? But what we want to make sure is we go back to our 303.2 from the IPC, or the residential requirements for plumbing systems, and make sure that we are looking to install them in accordance with the manufacturer's installation. Does that manufacturer say we need to put a polyplastic, polyurethane coating? Does it require us to do mineral wool so that we don't have, the pipe sweat interacting with a cellulose or some other material that would become affected more by that moisture condensation? Are we going to install those pipes inside a wall system that might be, again, prone to freezing, right? And so again, are we going to, we see in this diagram where we're going to install a 1-inch pipe insulation around the pipe that's running through the insulation. We want to make sure that we don't compress this insulation. We also want to make sure that we still maintain that insulation. There's a variety of different components that we're doing. We don't just say, throw in the pipes wherever you want, we'll be back on Thursday to see if it's done right. No, we want to make sure it's designed as best as possible to understand where those fixtures are going, how the pipe is going to get there, and what level of protections and methods of installation are we going to be using, right, to get those fixtures where we need them. This also applies when we talk about those pipes and vents that penetrate our different systems, like our roofs or air barriers, right? If I have a system that penetrates our roof, the code tells me I need to put some kind of material, right? A sealant to restrict the entry of water into the building. But we also know that the energy code, like we said earlier, requires us to consider the impact on the air barrier. So again, it's a question of, is this my thermal envelope as we see it labeled, or is this roof system going to be my envelope? And then in that context, exactly as we see here, what are we going to do with the pipe that exists in the semi-heated space, right? Are we going to allow for that typical vent pipe, and then we've got hot air going up, comes into contact with that cool air during the winter, accumulates moisture falls back down. Now we have moisture accumulating on our bats of insulation, as well as in the relationship with our drywall, right? Or are we doing it in a way that we try to allow for moisture to dissipate, right? To give it more air movement. So there's a variety of different situations where we need to think about the warm versus cold climate impacts of that vent pipe, right? And so again, that's where we start to have this conversation, this dynamic relationship with our plumbing code and our energy code, because we don't want to create a system of problems or a set of problems. And again, we might see that on a plan where it says we're going to have some continuous, sealant, this beta sealant, as well as flashing at the top of the termination. So again, we want to make sure that we identify these in those plan details, so that we're not coming out there at the end saying, well, the plumber came out and said this is okay, so you can't look at it anymore. Well, no, there's plumbing connections and there's plumbing that affects building components. And so again, we have multiple types of codes. And so it's important to us to educate and reinforce those expectations between our different inspection agencies. Again, like I said, in my county, where I was working and have worked for many times, several different counties, they've all been this way. The plumbing inspector and the building inspector are in different offices, different buildings even. And so once in a while we have to get together and say, hey, we're all looking at this the same way, right? Just to confirm that we're talking about the penetration that goes through this assembly. We're expecting it. We are expecting it. It is required to have some type of sealant or caulking, and that we're considering these impacts. And so again, it's part of that communication that we see in that air barrier. We start talking, that's fixtures. We start talking about those supply distribution line sets. We start thinking about why are we distributing water through the system? Is it part of a hydronic heating system, or is it part of a surface water heating system? Are we looking at a mechanical space conditioning system, or a hot water to drink or to make coffee? Because if you affect my coffee, we're going to have problems, right? Am I like Pavlov's dog? As soon as I bring that cup within this reach, I have to drink. I think I might be. It might be a social experiment right there. Digression completely. But again, the code tells us that if we have the energy code tells us that if we have hydronic heating systems, space conditioning that uses mechanical piping to carry fluids, then we have to insulate them to a minimum of the R3. Why? Because we're trying to prevent condensation on the exterior wall of that pipe. Again, we're trying to control for condensation. Similarly, when we start talking about surface water heating systems, right? We're trying to get that hot water to the sink so that when we wash our hands, we have nice warm water. The code reinforces that we need that R3. Now, what we see in the code when it comes to these types of insulation requirements, what it tells us is that we have certain levels of insulation for water heaters, right? And we have insulation that's part of our piping system for the R2s, 3s, and 4s, as well as other than, right? So again, the IECC is redirecting us, saying, hey, insulation needs to follow the energy code. If you look at the UPC, the Uniform Plumbing Code, what it says is that if it's 2 inches, if your supply line is 2 inches or less, you have to put 2 inches of insulation. If it's 2 inches or more, greater than 2 inches, then you need to have the diameter of the pipe has to be the diameter of the thickness of the wall insulation, right? So it's giving me the size of the insulation. Well, if there's one thing we know from the energy code, it's not a question of the thickness, it's a question of the thermal resistance value, right? We talk about that all the time. It's not that I need 4 inches of insulation. I need this R value of insulation. So you can tell me 4.5 inches of insulation, but until you tell me what that is giving me as an R value, I'm not going to accept it because I need to know the resistance value, not the general thickness. Because I can do 4 inches of an R3, give me to an R12, or I can do 4 inches of an R8 or R7 and give me an R20, R28, right? I can have completely different expectations of that insulation. And that's why we see in the IECC the reference back to the energy code to say, hey, make sure you know we're looking for a level of insulation that matches that R3R that we're seeing in the other code. And again, when we look at commercial, same concept. Hydronic heating, surface water heating. They need to be insulated. They've got a table that gives based on the value of the insulation as to what's expected, right? And beyond that, it also gives us the ability to use either a heat trap, right? To again, we'll talk more about the heat trap, or we can use heat tracing, right? And so what we're looking for is that heat trace is going to give that hot wire that will allow that pipe to maintain temperature given the exterior environment temperature. And so there's going to be certain expectations of how we use those systems together. If we look at that, I think I shortened it in order for us to see the table. So when we start talking about that table, based on the temperature of the fluid going through it, right? If it's just a hot water line between 105 and 150, right? Based on the size of the pipe, that's going to tell us how much insulation we need, right? We can understand what we're looking for and that thickness and our thermal ratings. One of the things that we also see again is when the energy code, especially in commercial, starts talking about how long what's the maximum level of pipe length of that pipe. If we're depending on the amount of water flowing through it, we don't want a pipe that's going to be endless in the amount of water that may exist between the source and the termination at any one time when there's no movement. Because what's going to happen is that's going to cool over time. Remember that R3 insulation is not going to protect it or keep it warm. It's going to prevent moisture condensation. And so what we're trying to think of is how much water is going to be wasted or exist in that pipe. And so we either can calculate the volume of that pipe, right, in ounces of water per foot of tubing, or we can calculate the maximum length of that pipe based on the size of the pipe. right? And so again, do we want to calculate the volume, calculate the length, whichever one we want to use, the code gives us that flexibility. But ultimately, what we're looking for is we want to make sure that if we are supplying hot water to something, that we're not going to be running that hot water across 300 feet of pipe before it gets to the final termination point. And this is a conversation that a lot of times when you do commercial plan, this is something nobody's really, very few actually look for this as far as designs, right? Once you want to make sure that your contractors are following this once in a while, spot check, or every time spot check, to make sure that we're not running a hot water tank across an entire commercial building and then running into, well, we don't have enough hot water when it gets there. So we got to run it for 20 minutes to reheat, retemper that entire length of pipe, that 15 gallons of pipe that ran through, in order to get to the other side. So again, digression, but again, the important thing to consider in that relationship between plumbing design and energy code compliance. And again, this kind of gives us some examples of how that's done, right? Zoom into those. Size of pipes, volume of liquid per foot. 2 inches or better, you're looking at 18 ounces per foot, right? And so depending on we want to have a maximum length of those public facilities of a half a foot, right? Between that and the last time we had a recirculating pump or something of that size. So again, here's the volume based on the type of material. Different sizes will allow or carry different volumes. It tells us the method calculation. Again, here we see it again as an example. And so we're looking at a half-inch. So you got a 1-inch cold water, 3/4 inch hot water, and a half-inch for the recirculate up to the second floor, right? So what we're looking at is, again, how are we getting that water to those different locations? And part of the recirculating pump is, again, to activate and make sure that we isolate areas of cooling water, right? So that we're recirculating or making sure that we're not trying to, again, force this across 400 feet, just to use a high number, for hot water, right? This pipe is only going to be carrying that pipe for so long. Another thing that we think about, to keep this conversation going, because I got plenty of slides left, one of the major components that we talk about in plumbing is going to be the service water heating system, hot water tanks. And so the code requires that we provide hot water, obviously, and that we protect that hot water. But and it also provides us this understanding that hot water could be used as part of a space heating system, right? But what we do want to remind ourselves is of, while we're thinking about the plumbing code and the residential plumbing provisions as they affect the amount of hot water we need, that the energy code has some considerations to come into play when it comes to that hot water service, right? The plumbing code says how much do we need. The energy code says, okay, now that you've got that piece of equipment, how efficient is it when it comes to energy use, right? And those different, again, considerations that we see when it comes to those controls, temperatures, and especially in commercial, we get into controls a lot more than we do in the residential. But when we start talking about these systems, again, it's a question of control, a question of performance efficiency, right? And so in the commercial, you've got the table that you can go back to and say, hey, what level of efficiency are we looking at? When we look at it from a residential perspective, we're looking at it as, where does it come in our minimum expectations for equipment, right? And so the commercial provisions also address large systems, high input service systems. So again, if we got 1 million BTUs or more, it gives us some some expectations, so that we're not always looking at that table like we do in regular commercial. But again, when we're thinking about that hot water system, especially in commercial operations, we're following a system where the plumbing code told us what size we needed, the energy code told us how we evaluated. So we see the plumbing fixture comes in. It tells me I'm getting a 50-gallon tank. It's going to have 76,000 BTUs of gas, and then it's going to be a 94% efficient piece of equipment. When we look at that from our table that we find at C404.2, we're seeing that based on the size and the capacity, we need to have at least 80% efficient equipment. We've got 94. We've passed that. We'll find that kind of information once in a while on a comm check. Similarly, I like to see that evaluation on my residential, right? If I'm looking at a residential water heater, I want to know what it is. And I'm going to say, is it going to meet my 80% efficient, my 78% efficient, depending on where I'm at in the codes, right? It's going to have to meet that. Now, one of the things I do want to point out for those that are going to be following a commercial project, especially one that require that some of those designs may allow a project to meet its requirements for additional efficiency credits or requirements. So if we see here in this example, right now we've got a 94% efficient furnace or efficient water heater. If we went to 95, then we get those additional efficiency credits. So it may be something easy for us to say, well, we're going to make this a little bit more efficient. We're going to go to 96. It's going to be just, it's going to cost the same, but now we're going to get those extra credit points that we need that we don't have to do later in a different system. Same thing in the reduced use in residential, right? We start reducing that amount of energy used for surface water heating because of efficiency designs, then we can start to bring down, right, what we're expecting. So if it's an 82 or better, we're going to be able to take into account some of those efficiency expectations. Now, like I said earlier, this is a real conversation that we have all the time when we start talking about that relationship between different codes. And so when we start talking about, we've got an existing system, we come back to replace it. The energy code says I need to have an alternate new equipment. It needs to follow the energy code. So I'm going to be thinking about it there. One of those realities, like I said, my sister's looking at, what kind of replacement water heater. And part of the conversation was looking at, she was looking at a tankless. And I said, well, one of the things you want to make sure you do is you think about how big is your pipes to get to that location. This is a very similar design to what she currently has. She has a gas furnace and a gas range and a gas water heater. And so they came in about, so it's, when this was installed, it was sized to provide you, enough gas to get these systems to fire consistently. If you go to a tankless and you buy and you need to start to evaluate what is the gas requirement, right? If you increase this gas by 4 times, is this system, either the piping itself delivering it or the regulator at the street, capable of sustaining that level of demand? Again, alterations, repairs can impact the size, the pressure, the meter, all of those things. And so it's not just a simple, we're going to change it out and swap it out, and it's just a plumbing conversation. It may have bigger implications. Like we said earlier, when I think of traps in that conversation of plumbing code, I also think of integrated heat traps. Remember that heat trap is going to be designed or at least detailed to be in your water heating equipment to provide a structural component, right? A modification to the line that prevents or impedes the amount of cold water re-entering the heated tank, right? As that pipe sits there, and again, think about this. Last week I was in Texas, saw many of you there. My family went to camps or we're on vacations, and so for pretty much an entire week, no one used no one was home, right? And so what would happen is naturally, without that heat trap, that water sitting in that pipe, right, that's going to the back bathroom, all the appliances, right? It goes to the washer, it goes to the dishwasher, it goes to the kitchen sink, goes upstairs to 2 different bathrooms and plumbing fixtures there. All of that water over time will cool. And then that cool water without that trap will just naturally, uncontrollably flow right back into this water tank. And that water heater is going to do what? Recycle more. It's going to turn on for a little bit. As the temperature gets down low enough, it's going to turn on. Even though no one's going to be home for a week to use it, it's still going to use energy. So what the code provides is that we're going to have some kind of a heat trap or heat trace, as well as possibly even controls, right, that tell me that if this system isn't being used, it doesn't need to be reheated. right? If we're going to so that's what we're looking for is some type of temperature maintenance system that says, hey, if you're in a commercial and sometimes in residential temperature, right here, residential R40351, automatic controls, temperature sensors, and pumps shall be located in a location with access, right? We want to make sure that we're controlling the temperature even though no one's home so that we're not overcompensating. If we go on vacation for a week, we automatically turn off the pump, right? That recirculating hot water pump when there is no demand for hot water. There's nobody home. The pump doesn't need to run, and the tank doesn't need to compensate for hot water being lost, heat being lost. Same thing in the commercial zone. We'll see that once in a while. I was actually looking at a plan yesterday for a new building going up where they have integrated the same door occupancy or occupancy sensors we see in commercial into a traditional regular residential unit. So when the kids go into, I'm assuming the kids based on the names on the rooms, when the kids go into their room, the heating system turns on or resets, right? The temperature will reduce to a certain level when no one is in that room. And when they go into the room, it will reset. And then when activity is no longer sensed for 20 minutes or more, it will reset and return to that lower temperature to reduce the amount of energy. Same concept with their water system. It's connected to their entire building so that when they actually go into a room, it starts to think, well, what if somebody wants the bathroom? They walk in the bathroom, it starts to get the pipes ready, right? It sends that potential, hey, we may be needed, right? So again, we're starting to see that and more technology integrated into our systems to make buildings more efficient in how they operate, right? And again, here we see again more demand recirculation controls being required and identified. Now this one, in commercial, it's demand recirculation water systems shall have controls, right? And so we're in residential, it's where installed will have these controls to turn off the water when the presence, sensing the presence of a user, right? And so again, at this point, it's more of a, if you're going to do it, you're going to do it this way. And maybe in future versions that becomes a little bit more of it's a requirement. But more importantly, I'm seeing this more and more in designs where people are trying to better use to decrease the size of their system in order to compensate through intelligent controls. Remember, the plumbing code and the plumbing provisions do not restrict the size of a tank, right? It tells us the minimum amount of a tank, but it does not give us a maximum, right? If I had, now you guys know I have 4 children, 3 boys and 1 princess. And so if I had 4 princesses, I guarantee that I would have gone with a 500-gallon water tank, right? It wouldn't have been 50 gallons. It would have been 500 because I know that one young female in my home can spend a lot of time in the bathroom getting her hair just right, taking that 20-minute shower that drives me crazy, right? And so again, having that kind of technology may be something that we see come into a design, especially with some of with the way we're designing buildings newer and cooler every day. Again, we see here if we're using a heat trace system as part of our residential design, we need to make sure that it adjusts to maintain that temperature, right, when it's needed. So it's not constantly on 24/7, 365. It's on when we're looking at that temperature that's needed. That's both for residential and for commercial. Again, turn off that heat when we're trying to control it. Now, one of the things that when we start talking about some of these systems, I've seen it employed and utilized in designs where there's concern about freeze thaw, right, or pipes freezing. That's probably not as big a problem in the panhandle, but if it becomes a problem, this may be a good alternative for people that don't want to insulate below or in certain areas, right, whether that's above in an attic or in some kind of a pipe chase, and they may choose just to go with some kind of a heat trace system to maintain the temperature of that pipe to prevent any potential damage. I see this in a variety of different settings. I've seen it in steel framing, where we're trying to maintain the temperature of the steel so we don't have to insulate. I've seen it in pipe chases and industrial side units. We have a lot of we have fresh vegetables, I don't know if you guys have so much of that. You have more cattle, but we have we have a lot of farmland, and so in some of those cooled industrial complexes, they will actually put heat trace on the pipes as they're in the building because the temperature in the building is low enough that they don't want those pipes to freeze inside, right? We have buildings that maintain temperatures at subs in those 50s and 30-degree temperatures. And so the pipe chases have to be insulated to protect against this. So again, it's not just a prescriptive concept. It can be something that we can see designed in other ways or utilized in other designs. So digression. It's a great way to control for thermal bridging and that kind of thing. One of the things that, again, we see this in the commercial side, and like we said, it sometimes will start to creep its way into residential, is going to be all of those controls. Again, making sure that we are not constantly, again, if we have if we think about downtown, we think about the city building, municipal building, or some of those offices downtown. When the employees go home at 5 o'clock, there's no need to run those tanks again, right? Those tanks can actually go into a shutdown or a lower maintenance temperature than when there's actual people on site. Again, I've seen this happen a few times. I've seen it in residential where, again, that occupancy when it's unoccupied, it reduces it maybe to 100-degree temperature, and once the building is occupied, then it increases back up to that 140, 130, temperature. So that 30-degree modification is much easier to manage than that. Than maintaining that difference over an entire 16-hour period. So again, this might be something that you see, and more importantly, I bring this up as we think about some of those compliance path options. When somebody's using a cost-based compliance, this can actually be something that gets brought up. How do we control those systems, right? I'm going to be spending money regardless of whether, when this is running, regardless of whether or not there are people in the building. And so that might be a way to reduce energy consumption and therefore energy costs by putting in advanced controls that decrease or affect the heating equipment based on occupancy levels. So again, residential, commercial can be both ways, but again, we talk about those drains, like I said earlier. One of the things that we see identified is going to be that drain water heat recovery system. Now, the code doesn't say you have to have it. It's where installed. But what we're looking for is to make sure that if you're utilizing the natural heat inside an exhaust or not exhaust, a waste drain, right? Some drain water, some drain system, and you're using that existing heat to return back as hot water or return the heat of the conductive nature of that heat into the water tank. And again, there's certain standards. That's the whole point, right? The whole point is if we're using a different system to recapture some of that heat, we're going to make sure it follows that CSA when it comes to those designs. One thing I think is important, again, to think about in that context of both residential and commercial, it's not necessarily in the plumbing code or the plumbing provision so much but it does affect water. And so I thought it was bring up is, again, those pools, whether that's residential or commercial. I put the commercial here just because of why not. But, residential or commercial pools that are heated pools are required to have certain controls for their heating, whether that's a timer switch or something that says when it's being used, it's being heated. When it reaches a certain temperature, it's being, the heater turns off. Again, if it's a cover based on the information that's there, is that heat being provided by on-site renewables, or is it just, again, part of the normal heating system? Then we might require covers, right? There's different expectations, and that those exist for those types of systems. Again, I think that's one of those things when we talk about residential, you don't really think about it as much. And most of the part, remember, the biggest thing to remember is if it's a heated pool, not just a pool, but a heated pool or spa. That's when we're talking about these systems to make sure we are controlling and evaluating how they're controlled and how much energy is being used in the system. Well, it looks like that's what I've got for plumbing systems. If you have any questions, please let me know. Put them in the chat. Raise your hand. We can talk about them. As far as upcoming training, it does look like we're on next Thursday, on the July the 3rd. We're going to get back into our plan review series. Now, remember, this is a new half the year, so we're changing it up to where it's the first Thursday of every month is going to be plan review. The third Thursday of every month will be inspections. Those other months are going to be topical. And so we're going to get into, again, what documentation, air barriers, breaking down the res check, com check reports. So we'll have that conversation. Hope gave me a series of different, and we've talked about some different trainings coming up for the next couple months. So I'll get those lists updated, both on our slides and everything. Remember, for those that might be interested in learning and doing a little bit more in the manual J, D, and S calculations or report reviews, feel free to share with anybody our upcoming training on Tuesday. Let me see if I got it still here. I had the link earlier. There it is. So if anybody's interested in participating in that free 4-hour training on Tuesday, July the 1st, it's going to be 8 a.m. Mountain, which is 9 a.m. Central. And so make sure if you're interested in that, you sign up, register. That's free. And it will be, again, I think Andre and our Jesse will be hosting that one. Again, running through the manual JD&S. When you exit, make sure you take time to fill out your survey. If there are topics or training conversations you want to have, let us know. One of the things we're looking to do, I'll be back, I think, on, we're getting some final confirmation. I'll be back on the 16th of July, and in town on the 16th, doing a training on the 17th. And then we're going to have our codes and coffee on July the 18th, Friday morning. We'll do some coffee. There might be the potential we might do another prepping for plan review certification exams, a very focused class, maybe there in the afternoon on the Friday, but we'll be talking about that to confirm some dates and some times. But I think that's going to be an opportunity for us to get together. But most importantly, I think we're going to do codes and coffee on that Friday at the hosted by the Builders Association. And I think it's going to be at the Habitat for Humanity, if I can make sure that's the right site. I'll get those details together, ironed out this week, hopefully, and get emails out next week for that July coffee time. But if you have any questions, again, feel free to reach out to us. You can always use the Texas helpline. To do that, it goes to the entire team. If there are contractors or designers that might have a question as well, and you want to push them off on us, to get some assistance, and they're interested in, maybe they can always use that as a way to get some extra information. Feel free to share that information, that email with them. Again, anything related to the energy code, or generally, and as I always say, pretty much the entire code can be turned back to the energy code. So we're there to help, and if we need to, we can jump on a Zoom with them to get them to what we need them to be. So you guys have a great week. I'm not seeing any comments in the chat. So you guys have a great week. Be careful this weekend. And again, I'll see you. If I don't see you on Tuesday, I'll see you on Thursday the 3rd for our next webinar. You guys have a great week.